Right, today we're going to use Lego to try and simulate a particle model. So what I want you to imagine is we've got a really powerful microscope that enables us to see all the particles that things are made up of. All right. Now, if we imagine that Lego bricks, each Lego brick is a single particle of something. Now, sometimes, like my gold wedding ring, where all the particles in my gold wedding ring are exactly the same type of particle. So that's like just having to build with grey bricks. Now we can still build some impressive things out of just one type of particle, like my gold wedding ring is quite an impressive structure. So you can see here we've built a grey brake van, and that's just got grey bricks in it. Okay, so if we have just one type of particle, we can still build some impressive structures. However, if we have more than one type of particle, we can build really impressive things like this Class 66 diesel electric locomotive that's got lots of different coloured particles, lots of different shapes. So that's a bit like our bodies, which are made up of iron, or the teddy bear, which are made up of iron, carbon, hydrogen, oxygen, sodium, loads of different types of particles. So if we think about our particle model from yesterday, some things like my gold wedding ring are made up of just one type of particle. Some things like us are made up of loads of different types of particles on there. What we're going to have a little look at now is how those particles are arranged. So one way to arrange the particles, again, if we just imagine we've got our Lego bricks here, if I put them into this glass dish here, I've just filled it with particles in here. The particles are now free to move. You can see them moving around in there, and they're not stuck together. So this would represent a liquid. So in a liquid, the particles are close together. Okay, you can see they're all next to each other, but they're not in any fixed pattern, and they're free to move. Alternatively, we could have them all in a wall. So if we look at what I'll make, imagine them all in a wall just here, like this, okay? Here the particles are close together, just like they were in the dish, but this time the particles are all in fixed positions. They can't move, and this represents a solid. So if we think about solids and liquids, they have something in common. In both of them, the particles are fairly close together. So if we have this little model here, where we've got the particles in the wall, okay, and the particles in the dish. Both of them, the particles are really close together. The big difference is here, the particles are free to move around, whereas here, the particles are in a fixed position. So this represents a solid, and this represents a liquid. The solid,
what's this?
That's a solid, isn't it? Because
it's squishy.
It's squishy, it's a squishy solid, but he's a solid because he's got a fixed shape. Now this one here, you can see it doesn't matter which way I turn it, it always has a fixed shape. Whereas my liquid will take the shape of whatever container I can pour it into in there. So depending on what the shape of my container is, it will take that. Now I want us to think about if we want to turn a solid into a liquid. Could I do anything, Sophia?
You could melt it.
I could melt it. That's right. Now, how would I, in my model, how would I go about melting it? What I need to do to the box? Can you do it? Brilliant. Can you break? Are they all broken up?
No, not all of them.
Not all of them. I'll break them all up then. Now, when Sophia's doing that, is she putting energy into the system, or is she taking energy out of the system? But she was quite right. She was melting. So melting is the turning of a solid into a liquid, and what happens when we turn a solid into a liquid is we break the particles apart. Now, of course, the reverse of that, if I want to turn a liquid into a solid, can you think what we would call that, Sophia?
You'd freeze it.
Freeze it, brilliant, okay. Can you think of anything in the kitchen that can do that?
A freezer.
Brilliant. Does there any time of year when it happens outside?
No. Christmas.
Christmas. Do you know
winter.
What temperature do we need to get water to turn into, what do we call solid water?
Ice.
So what temperature do we need it to be to turn solid water into ice? Do you know what temperature?
No.
You don't. Right, well, I wonder if anyone at home knows that answer. Now I want to think now, if we're going from a liquid to a solid, am I taking energy out of the system, or am I putting it in? So these particles here are constantly moving around. Are they moving here?
Now.
So if they were moving and now they're not moving, have they got more or less energy?
Left.
Less. Brilliant. So what happens is when we freeze something, we take energy out. When we melt something, we put energy in. So to change things from solids to liquids, it's all about putting energy in, taking energy out, and it's all about getting the particles, changing them from being in a fixed position like that to being able to move like that. And in a little while, we're going to have a go at drawing some particle models, and we often draw particle models as circles. But unfortunately, circular Lego wouldn't work. It wouldn't stick to itself like that. Now, as well
No,
as
but you can get circular Lego.
yeah, but they would stick to each other.
Yeah.
And have we got loads of circular bits?
No, not
No,
those.
we haven't got enough, have we? So we're going to have to do it using this. Now, your next bit, Sophia, is we've got a solid, we've got a liquid. What's the other form, which particles can exist? Do you know?
Gas.
Gas. Brilliant. Okay. Now, if I had a gas, okay, does a gas have a fixed shape? No. Now, gases, it's really going to be difficult to measure. Imagine within a gas, if I shake the jar and you get the particles moving much, much more, that represents a gas. So in a liquid, the particles are not joined together and they're free to be able to move on here. So they're free to move. In a gas, the particles are moving even more and they spread out even more. So to make up to model a gas, and I'll put them in here and shake them, okay, that's a gas. Now I want you to imagine if I could get a camera and just freeze this in midair and I'd have all these particles moving around a nice distance from each other. It's impossible. I can't freeze it. Just imagine I could freeze time and we could see a gas. A gas, I can maybe lay it out on the table, okay, like this. A gas would have the particles far apart, but all being able to move around. A liquid would have the particles all able to move, but close together. And a solid has the particles close together, fixed positions, unable to move. However, said that, within a solid, they are able to vibrate and move a little bit like that.